Alright guys, in the last video we left off talking about different notations for log, right? And we said normally we write log base of something, well base something of x. But we said if this base here is 10, so if a is 10, it's usually written as just plain old log. However, if this base is e, we refer to as log base e of x as ln of x. I don't really know why they do it, honestly, but that's how it is. So don't get confused when you see ln or just plain log. Just treat it the same way, as if it's log base 10 or log base e of x, okay? So the natural log, let's zoom in so we don't get lost here. So the natural log is just a regular log function with this unique base, but it follows the same properties as a normal log, right? So ln of 1 is 0 because e to the 0 is 1. ln of e is just 1 because e to the 1 is e. And just like how we had for our log functions, in the last video we went over the properties of log. We had an inverse and a one-to-one property. We have the same thing for ln. So pretty much the same rules apply because it's literally the same thing, just different base. Okay, so it's important to know all these properties because they all come together and they're all very useful for finding our missing variable, or our unknown variable, I should say. The other thing we should know is that there are some operations that we can do with logs. So the first one is this, the product property. If you have something inside your log where it's two things multiplying, you can break them up into like an addition. So for example, if you have log base 3 of 7 times x, you can break this up into log base 3 of 7 plus log base 3 of x. Oh, well, So all of these should actually say ln. I totally made a mistake there. So all of these, so this whole rule applies to ln. So all of these, I'm sorry about that, I should have fixed that. All of these should be in ln, ln, ln. So they're saying that the same thing applies to ln. If you have two things multiplied inside your ln function, you can break them up to pieces and connecting them through addition. Okay, so how about our second, the quotient property? The quotient property says that if inside your log you have two things being divided, you could separate them via subtraction. So if I have log of 3 over 4, you can break that up into log 3 minus log 4. And again, same here, this all is supposed to say ln, ln, and ln. I glanced over it, I'm sorry about that. So the same thing, so if it's multiplication, you can break it up into addition, and if it's division, you can break it up into subtraction. These rules come in handy a lot, so make sure we know them. The last thing here is the power property. So this is probably the most common use for logs, actually, is to bring down this exponent of n. It says that if you have log base a of something to the nth power, it's equal to n times log base a of u. So for instance, if I have log base 4 of x squared, anything in the exponent, I can just bring down and multiply my log function by. So it's equivalent to 2 times log 4 x, just like that. And the same thing applies for ln. This one I did get right. I did write ln. So ln of, let's say, u to the 2x plus 1. Well, all I'm gonna do is drop that exponent down and multiply it by ln of this guy. So the cool thing about is anytime you have an exponent inside the parentheses, you can always take it out and bring it back to the bottom, or like on the same line as your ln. So we're not really working with too many exponents here. Okay, so our goal here is to use these rules and see how they kind of work. I mean, we got a good glance at them right now, but we'll do about 6 more examples using all this. Let me just erase all this or it's gonna bug me. All right, so let's start with this one. The goal here is to write these 2 examples in terms of ln of 2 and ln of 3. So let's look at the first one. We have ln of 6. We need to go from ln of 6 to equaling some combination of ln of 2's and ln of 3's. Well, one thing I do know is that 6 can be broken up into 3 times 2, right? 3 times 2 is equal to 6. So I went from having 6 to some sort of product. Well, I have a product. That means I can use my product property, and I can break up these guys via addition. So let's go ahead and use the product property right there. So equals. I'm going to split up my product into ln of 3 plus ln of 2 into addition. Not bad, right? I feel like it's pretty straightforward. All right, let's work on the next one. Okay, so we're supposed to write these in terms of ln of 2 and ln of 3. Right now, we can't really do much as far as dividing anything goes. So let's go ahead and use our second property. See, inside this parentheses right here, we have some sort of ratio or quotient. So let's try to use the quotient property. So the quotient property says that if I have something divided by something inside my parentheses, I can break it up using subtraction, right? So this guy, I can break him up as ln of the numerator minus ln of the denominator. It's really important that you follow the same order that they do on the quotient rule, right? So notice how they do the numerator minus the denominator. So what does that mean? If you were to write this, ln of 27 minus ln of 2, you would be incorrect because you did denominator minus numerator. But we need numerator minus denominator. So just be aware of that. Keep your eye out. Okay, so now we definitely have something in terms of ln of 2, but this ln of 27 is not in terms of 3. So we have to figure out a way how to break that up. So one thing I do know is that 27 is equivalent to 3 to the third power. So now I have my base 3, but the only thing is I have this extra 3 in the exponent right here. I got to get rid of that guy. So how do I get rid of him is, well, I use the last rule. I use the power property. And the power property says that if I have ln of something raised to something, I can take that exponent and bring it down and multiply it, my ln by it. So I have ln of 2, and I'm going to take this guy, this 3, and bring him down in front. Ln of 3. So now we've successfully completed the task. Okay, good. So let's keep moving on. Another set of examples. So our goal here is to write things in terms of log of 5 and log of 3. So let's look at this question right here. Log of 75. So what can I do with this log of 75? Right now, it's definitely not in terms of 5 or 3, right? However, I do know I can make up 3 pop up inside, because I do know that log of 25 times 3 equals log of 27, because 25 times 3 is equal to 75. So 25 times 3 is equal to 75, so I can rewrite the above statement like this. But I also know that 25 is written as 5 times 5, right? So I can rewrite this whole sentence using our product rule now. That means it's the sum of each of these individual values right here. So I can have log of 5 plus log of 5 plus log of 3. Almost done. What's log of 5 plus log of 5? Well, it's like saying what's x plus x? It's just 2x. So I have 2 log of 5 plus log of 3. So that's our final answer. And I don't know why I gave no room right here. Stupid of me. So we'll go on this side. All right, last one. We have log, what do we have to write in? 5 and 3s, right? So we have log of 9 divided by 125. So we see that there's some sort of ratio or quotient. Let's go ahead and use the quotient rule, which means I can break apart this guy using a subtraction sign. So I have log of 9 minus log of 125. Remember, I want numerator minus denominator. But we want things in terms of 3s and 5. So I rewrite log of 9 as, you know what, the smarter thing to do, it's okay, it's fine. So we're going to write 9 as this, and we're going to write 125. Well, I feel like we just did 125, didn't we? Oh no, we did 75. How are we going to break up 125? Well, there's a lot of ways to do it. Let's go this way. 5 to the third power. Okay, so hopefully everyone's following. And the last thing I should probably do is get rid of these exponents that are up here. How do I do that? I use the power rule. The power rule says that if there's an exponent inside your parentheses, just bring it down in front of your log. So I'm left with 2 times log of 3 minus 3 times log of 5. Alrighty. Wow, there's a lot of questions here, huh? Alright, we'll keep grinding away. Okay, let's look at the next one. We have log base 5 of cube root of 5. And my goal is just to simplify this statement as much as possible. So maybe we should start by rewriting cube root as a normal exponent, right? So log base 5 of 5. Now cube root can be represented as an exponent as 1 over 3, like this. And now because I can use the power rule, I can take this exponent, which is 1 over 3, and I can drop it in front of my log, right? So I have 1 over 3 times log base 5 of 5. That's using the power rule. But the other thing is this. If your bases, oh wait, here, makes it easier to explain. Let's go here. If I have log base A of A, this whole thing will equal to 1 because A to the first power is equal to A. So we have log of 5 of 5. So this we know using this rule should equal 1. All right, so let's go back and fill that in. Okay, so this whole thing goes to 1. So I have 1 over 3 times 1 times 1. So it's just 1 over 3 is our answer. All right, last one we'll do. ln of e to the 6th power minus ln of e to the 2nd power. Let's see if we can use another rule, a quick rule here. Let's see, here we go. If I have ln, I'm looking at number 3 right here. If I have ln of e to some number, that whole thing evaluates to just that number. So let's go back. I have ln of e to the 6. So this whole thing simplifies down to 6. Minus, if I have ln of e to the something, it simplifies to 2. So my answer here is just 4. Good. All right, a couple more and then we're done. All right. The last thing we're going to do is working on expanding and contracting expressions. So it's just pretty much what we just did. All right, so let's keep going here. How can I expand this guy as much as possible? Well, the first thing you should realize is that all of these guys on the inside are being multiplied to each other. So we're going to use the product rule. So log 4 of 5 plus log base 4 x cubed plus log base 4 of y. So we're almost done here. We didn't simplify fully because we still have an exponent of 3 right here. So to fully simplify, we should get rid of that guy. And we already know what to do, right? Now we know how to use the power rule. So our final answer will look something like this. Log base 4 of 5 plus, I'm going to drop down this 3 using the power rule of x plus log base 4 of y. That's our final answer right there. All right, that's usually when I say, does anyone have any questions? But okay, so next we have ln of square root of 3x minus 5 divided by 7. So first thing we see is that there's some division, it's a quotient. So let's split it up, okay? So using the quotient rule, we can write this as ln of square root of 3x minus 5 minus ln of 7. We would be done, except that this guy still has an exponent. What is his exponent? Well, we can rewrite square root as 1 over 2 as an exponent. So the last thing we should do is probably bring down this exponent. So we'll have 1 over 2 times ln 3x minus 5 minus ln of 7. I think you guys are starting to get the hang of it. We're just recycling these same rules over and over. We'll do one more expansion one, and then we'll do two more contracting, and then we'll be done. So again, we have a quotient, so we'll split this up via subtraction sign. We have log base 3 for x squared minus log square root of 7. Okay, so we have a couple of things happening here. First, we have a product, and then we have exponents in two different places. So we'll deal with the products first, and then we'll deal with the exponents, okay? So let's break up this guy, this term right here. So this guy breaks up into, using the product rule, log base 3 of 4 plus log base 3 of x squared minus log of square root of 7. Okay, so now let's go ahead and deal with the two exponents, which is 2 and 1 over 2. 1 over 2 being the square root. So we have log base 3 of 4 plus, dropping down that exponent, log base 3 of x minus, dropping down that exponent. These are the exponents I just dropped down. Log of 7. Oh wait, there should be a base 3 here. I'm crazy. All right. Last two examples, and then we're done with this video. It's been a long video, but I think you guys will. It's good to learn how to manipulate these things, because it's going to be on your final. Okay, so for these two, we're just contracting them. We're trying to make them as compact as possible. Okay, so I see that I have two logs here, and they're both being multiplied by some number in front of them. So when does this happen, when there's a number in front of our logs? It's usually when we bring the exponent out from inside the parentheses to outside the parentheses. So now that we're not expanding, we're contracting. We're going to take these numbers and put them back into the parentheses. So we're using the reverse of the power rule. So it's going to look like this. X to the 1/2 plus log of to the 3rd. So I'm using the power rule, but in reverse. All right, so the other thing, there's two things to note, right? First thing is that we could turn this guy into a square root, but more importantly, the big thing to note is what? It's that there's an addition sign here, and the addition sign means that there was a product rule that occurred. So what I'm going to do is I'm going to use the reverse of the product rule. I'm going to say log of, I'm going to turn this guy into a square root. Square root of x times, so remember the product rule broke these two guys apart into addition, but now I'm just bringing them back together. So x plus 1 cubed. That's our final answer. And if you don't believe me, why don't you just try the strategy that we just learned above of expansion? You should get back here. All right, last one. All right, so we have ln, two different ln's, and this guy has a number in front of the ln, so that exponent probably came from over here. Or I should say it was once an exponent over here. So let's go ahead first and put him back in. So we have ln of x plus 2 squared minus ln of x. Now note that we have a minus sign. So in our previous step, we used the reverse of the power rule. Now we're going to use the reverse of the quotient rule. We're going to contract these guys. So we're going to have ln. Remember, this was numerator minus the denominator. So I'm going to have ln of the numerator. I don't know what I'm doing anymore. This video is long. Okay, I have the numerator divided by the denominator, which is x. Okay, so that's it. We'll see how this is useful in the next video because we have to do some real world applications. All right, guys, thank you for sticking around.